that. Thank you very much for having me. Please feel free to interrupt at any time. This should be interactive, but you don't have to do any coding unless you want to. A few sentences about myself. My name is Daniel Huppmann. I used to be a modeler once upon a time. Started at IASA as a postdoc 8 years ago, but then I got sidetracked into this whole database scientific software stuff. The stuff that everybody kind of wants to be done, but nobody wants to do themselves. Like everybody's happy that there is a database and there is a package as long as they don't have to touch it. And I'm the person who is basically chief minion of the IASA Minion Club, who makes sure that the database works. I'm also the grumpy old uncle who will tell you, use version control, please better document all the work that you do because you will not remember it. Now you'll do your group work or your dissertation or your research projects, and you'll say, oh, this is super easy. I'll remember what I was thinking. And then half a year later, the reviewer comments will come back and you'll say, I have no fucking clue what I was thinking. And then I will come and I'll say, I told you so. So yeah, but I'll say it in a nice way. So for the next 1.5 hours, I want to present a bit about the machinery behind all the cool work that has been shown by Nico and Zoe and that will be presented. We all do this great analysis, super important. How can we mitigate climate change? How can we reduce our emissions? But in order to do this kind of research in an effective way, we need common data formats. We need an agreement on what do we talk about when we say CO2 emissions, CH4 emissions, primary energy, final energy, etc. So I'll do a first like 15, 20 minutes presentation on some of the background and also the design principles of this Python package that we've been developing over the last 6 years. And then I want to run with you through a tutorial that shows you what you can do with PyM. And the aim of the tutorial is to prevent you from doing stuff yourself that could be done by a package that already exists. I see this all the time, like, oh, this is super easy, I'll just code it myself. And then 3 months later, you have 10,000 lines of code and it breaks and you don't know why, and you cry and you're sad and you don't get a dissertation. And I want to prevent that. So that's why I want to show you that there are tools out there that you can use that will hopefully prevent you from crying. Okay, motivation. There is a model. Everybody has a model. Everybody needs to have a model because that's what we need for doing research, for doing this kind of policy analysis, etc. And then there's a long process. You need to process your model output. You need to validate your scenario results to make sure that it actually makes sense what your model gives you. You need to do some analysis, some visualization. And in the end, you hopefully have some results, some insight, and a scientific publication. And Kai Ivar tomorrow will talk about the data visualization much more. Like he will tell you how you can actually get from interesting insights to insights that people actually want to look at. So all the data visualization, come back tomorrow. Today, I'll talk about the boring part, about the processing, the data formats, the database, blah. The problem is, if you look at what tools are out there, you have a big divide. So there are a lot of models, like the Remind model that Nico has been working on since 1999, he told us this morning. There is the Times model, Osmosis, Message. There are all these models, and they are well contained. They have tools to get scenario or to process scenarios to get that processed. So you run a scenario, you get some output. And then if you want to do some standard operations, each of these frameworks has some functionality. But then usually this functionality is not enough to do everything that you want to do for your policy analysis. And what you then have to do is you have to go to these general purpose plotting and data visualization tools. So if you go to R, there is tidyverse. If you are in a Python world, there is NumPy and Pandas. And the problem is we have this huge divide from these very model-specific, modeling framework-specific toolboxes to something that is super powerful and can do everything, but there's also too powerful for the average user. And what the PyM package, and then also PIC is working on an R tool that can do similar things, is trying to do is provide something in between. Something that is not wedded specifically to one modeling framework. So you can use it for different model outputs, but something that is still targeted enough to allow you to efficiently work with your data. And I'll show some specific examples in this tutorial notebook I'll run through later. It's now kind of understood that if you have a model, you need to do version control. If you look at all the good modeling frameworks that are out there, message, remind, times, etc., they are all in some version control, best practice, documentation, etc. Where this has not yet happened is for analysis scripts. So people run their models. The models are great, version controlled, software development, best practice. And then you take those results and you munch them up for your analysis. And then you munch them up more. And then reviewer 3 comes in and says, oh, you need to do some more. And you end up with 10,000 lines of analysis code that you don't understand anymore if you come back to it 3 months later. Or there is a dependency update. So one of the packages that you use in R or Python makes some changes, and suddenly your code doesn't work anymore. If this has not happened to you yet, lucky you, it will. There is a word called code rot. So code is rotting away when you're not nice to it. Nice to it being, you have to open it, you have to run it, you have to make some like little strokes and touch it and make sure that it still works. If you don't do that, after a year, the code will just rot away. And you'll regret it, because then it will be a deadline and you say, oh, I'll just briefly rerun my analysis, and no, you won't. So I want to guard you against this behavior of, oh, I'll just do my analysis script step by step. A couple of the big problems that I've done myself when I was a PhD student, copy pasting of snippets of code. So you do something in one project, then there's a new project and you say, oh, I've done something like that before. You just go copy paste and you copy paste all the bugs and all the bad implementation over to a new project. Yeah, version management of analysis scripts. Very often it happens that you write some cool analysis script and then you change it because you think, oh, that was a bad idea. And then reviewer 2 comes and says, oh, why don't you do this analysis? And you say, oh, I've done this before, but yeah, it's gone. I don't have it anymore. So that's why you should use version control, version management, in a way that you actually find again what you did half a year ago. Documentation of code. We are all ignorant and we are all hubristic. And we think, oh, we'll remember because we are smart. And we are smart, but not smart enough to remember every line of code that we've ever written. So help yourself by writing more documentation in the code. And then the testing and continuous integration strategy, I'll leave that out. Why is this a problem? Because we want to have open and reproducible research. We want to do cool research. We want to publish papers. And then if people come to us and say, hey, you've done this really cool paper, can you give me the code? Because I want to extend it. I want to build on that. And you say, yes, there's a GitHub repository. Take the code and run. Great. If you then say, oh, yeah, sorry, the dog ate my homework and I have done a cool paper, but I can't actually help you in reproducing it. It's not how science should be. Yeah, and then there is also this big problem of errors or bugs being proliferated over a project on and on and on. And at least for the next 1 hour, I want that we all agree that this is not how we should be doing it. And next Monday, you're back in your office and you'll all do it like that again. But at least now for 1 hour, let's just all agree that at least in principle, that's not how it should be done. Right, so why did we do this PyM package? I was the chapter scientist for the IPCC 1.5 degree report that came out in 2018. So I did a lot of the validation and vetting and analysis and visualization for the scenario data that was used for the IPCC report. So I did a lot of this, oh, I just write a script, and the script gets longer and longer and longer and longer. And there was a very nice person sitting next to me in the office called Matthew Giddon, and he said, that's not how you should do it. And then together we started pulling out all the methods and validation and plotting features into an own independent Python package so that we could easily reuse all the tools rather than having 10,000 lines of code that can do everything, but nobody ever understands why. Put it into a separate package. Using harmonized data structures. The big problem is that every model just spits out something in a different format. And then it takes you a year to understand what do they actually mean. The sooner we can start working towards harmonized data structures and formats, the more time we save ourselves to do cool research. I mean, we don't want to work with the data, so that we should just make sure that it's clean and nice, and then we can do the things that we actually want to do. We wanted to get away from this model-dependent features in this Python package. So it doesn't matter whether it's remind or message or PIPSA or any other kind of energy systems integrated assessment model. Why is it nice? Who of you has worked with Python pandas before? Okay, so roughly half of the room, that's great. Who has never worked with Python before? Okay, maybe a quarter of the room. So the design principles that we try to follow with this package, which I think is a general principle to follow whatever you do, is that everybody who has seen pandas, who has worked with pandas before, will look at PyM and say, well, it's obvious. It's like the obvious extension for how you would do this. And everybody who has never seen Python before will just accept it as is. Like, oh, okay, that's how you convert unit. That's how you do something with this data management package, visualization, etc. But then if you do that more and more and more, maybe at one point you'll say, okay, PyM is not good enough anymore. So you'll grow up and start using pandas directly. And again, what you have learned with PyM will feel natural going to the more sophisticated, more expert user level packages. So we try to not reinvent the wheel, but try to follow good practices. We have a lot of documentation. The main advantage is really shorter code is easier to read. So the more of your analysis you can hide away in some package, the easier it is for everybody else to read what you have done, or including yourself, that you can actually go back and look at the script. And everything that I'll show you, you could do yourself in 5 lines, but why do 5 lines if you can write it in 1? Much better. It's the exact opposite. So the question was for the online audience whether there was a speed detrimental. Yeah. Yeah. Yeah.
In like the same functions, but from a package.
Yeah. Okay. So the question is, are functions using from a package not usually slower than if you do something yourself? My experience is the exact opposite. If you code something for yourself, you'll just make sure that it kind of works, and you will not spend hours or weeks on making it fast. So if you go to a standardized, well-maintained package, usually there have been several people who have actually spent a lot of time making it fast and efficient. And again, for this PyM package, as an illustration of that, if you work with pandas, you usually work with pandas data frames, so big data tables. And they're useful. That's usual starting points. But there is also something called pandas series with an index, and they are much higher performance.
And pandas, is equivalent to tidyverse, or?
Yes. Yeah, pandas is equivalent to, is the Python version of tidyverse, kind of. So data frame management.
Okay, so I'll ask you later, because for me, I've noticed that with tidyverse, it works a bit slower because like you have to work with data sets and not with matrices, and like, but yeah, I'll ask you later.
Yeah.
Can I react to that as well?
Yeah.
Thanks. So even if it were true that it's that your scripts are faster, then you will get so much more. You will gain so much time by having less to debug and cleaner code. That even if it were slower, you will get that time back by a great factor. So it's really, that's really the experience that we have. It's just, otherwise you spend hours making a script faster or debugging it, and so it's a time investment. Yeah, you get it back. Okay, it was.
Yeah. Okay. Well, we can talk about that in the coffee break. The idea is that usually, if you're moving from some code that you hack together yourself to something that is well maintained by others, it is usually faster and it's usually better maintained. So guarding against code rot, etc. Okay, now diving specifically into this PyM package, but that was kind of setting the scene of how I think you should be thinking about doing your analysis scripts. The one thing that you need if you want to do model comparison, like we do in the Integrated Assessment Modeling Consortium, is a common data format. And 15 years ago, when I was still in kindergarten, the IMC came up with this wonderful tabular structure. So there is one column called model, one column called scenario, region, variable, unit, and then you have the years. So this is a horrible data format. Yes, I mean, using Excel, I don't know, there is this John Oliver. Yeah, just Google John Oliver, nothing good happens in Excel, and you'll have John Oliver shouting at you, nothing good happens in Excel. But the great advantage about this kind of data structure is that everybody kind of is familiar working with Excel. If you tell them, oh, we have this super sophisticated tool that works with netcdf files, 80% of the people in this room, if not more, will say, what the hell are netcdf files and why would I ever want to touch that? So the IMC made a, I think, smart choice by using a stupid format, by using something that everybody kind of feels familiar working with and getting started with, and not having this super high barrier to entry. One issue, if you just look at all the IMC data sets, is that they're always working just with yearly data. So if you look at what the IPCC is doing, what we're doing in Navigate, Engage, etc., it's always just yearly data. And of course, if you work in particular with electricity systems, you need a much more fine-grained resolution. So the PyM package now also supports hourly resolution and also representative subannual time slices, like winter night, summer day, peak hour, blah. The problem is nobody wanted to write a tutorial for that yet. So if you go to the PyM documentation, you'll see all the tutorials are written with yearly data. If somebody feels now very motivated to write a tutorial, PyM with hourly data, you'd be my hero. The important part here is that it works. And it's also integrated, tested, etc. Right, and then with different file formats, so it works with XLSX, CSV, and also the frictionless data package format. What it does not work yet with is netcdf. Has anybody here worked with netcdf before? Right, so we have 5 volunteers implementing netcdf integration for PyM. I think it would be a huge step forward for the community because XLSX is a really bad format, but I can't do it because, yeah, I've never understood netcdf. But I think this is also something where someone as a side project who has worked with it before could do that on the side. I mean, what do you do on a Sunday afternoon if it's raining? And it would be a huge step forward for the community by making the maybe 100 to 500 people already using that package being able to simply operate with a much more efficient data standard. Okay, so now this is the one slide summary of what can the PyM package do for you. Data processing, so going from your native model output to something that is much more efficient, going towards analysis, validation. Do your results actually make sense? So in my IPCC experience, I had a lot of modeling teams submit their scenarios. And then they said, well, the global CO2 emissions in the year 2020 are 40 megatons of CO2. And then I sent them an email saying, no, you have a unit issue. Please put 40,000 or whatever megatons of CO2. And you don't want to look at the data to see where's the unit error. You want to have a script that does that. So there is a PyM function called validate, where you say, is the variable emission CO2 in the year 2020 in the range of 38 to 42,000? And if it's not, raise an error message. So these are the kind of tools that are in this toolbox that can be useful for you to make sure that you don't produce crap. Or if you produce crap, at least you realize it early and not after you submitted the manuscript. We also have a paper in Open Research Europe where we write for 30 pages about how cool PyM is. And what counts as a hobby these days is I tweet and toot on Mastodon about this under the hashtag PyMIMC. So we really try to make it easy to use. Simple installation via PyPy and Conda. There are 2 manuscripts. There is comprehensive tutorials. There is a full-fledged documentation. So we try to make something for different types of users. If you've never worked with Python before, but you think, okay, this might be useful, you look at a tutorial, you sign up to the email list. And then once every 3 months, you'll get an email from me saying, hey, we have a new release, we added a feature. If you are a person using Slack anyway already for your work, we have a Slack workspace. So you can just sign up there and you can just in Slack shoot questions. And again, it will be me answering them. I mean, if other people want to answer, great, but at the moment, that's mostly me. And then it's all hosted on GitHub. So for expert users who really know how to do Python environments, how to do software development, they can directly interact with GitHub. So we try to cater to a wide range of users, that everybody, if they're using Python for the first time, they'll find something where they can hook into. And if it's like the 100th Python package that they're working with, and they know all the ins and outs, they also have a good way of connecting and contributing here. That's important for the people who want to do the NetCDF integration. Okay, so that was my spiel about how you should be thinking about your analysis, how we try to implement that in this PyM package, and the design principles. And now I want to take you through a live demo. If you want to follow along, github.com/DanielHuppmann/engage PyM tutorial. You don't have to. And I would rather not that everybody now starts installing it, because I think that would kind of just ruin the whole, I want to walk you through that. But if you say you're an expert user in Python, or if you sit in the back and it's too small to read, then you can just open the GitHub repository and just open the tutorial notebook and follow along there. Spoiler, I took out all the solutions from the thing I'm going to show. So if you look at it on GitHub while I talk, you'll already see the answer. There are no marks, so there's no point seeing the answer, but it might be still useful. One other comment that I wanted to make at the beginning and that I forgot. I always put QR codes on my presentations. So if you take out your mobile phone, you'll directly go to the Zenodo entry where you can download the PowerPoint presentation immediately. I started doing that a couple of years ago. I think it's super useful that you put the presentation already online before you start the presentation. On Zenodo, you can actually reserve a DOI. So you start an entry. You say reserve DOI, it will tell you this is the DOI, the digital object identifier, under which your resource will become available. You go to the QR code generator of your choice, you create a QR code, you put it on the slide, you save the slide, you create a PDF, you upload that on Zenodo, and then you click publish on Zenodo. And that way, everybody sitting in the audience can already go boom and look at the slides and save them. And then in case you can't sleep tonight, you can say, oh, I'll go through Daniel's slides again. They were super exciting. Why are you laughing? I also find that super helpful for posters. So there are about 24 really interesting posters out there. None of them has a QR code. Okay, sorry. I apologize. I went through, I didn't see any, but okay, apologies. Okay, there are 2 people who are already doing that, but I think that's also super useful for me when I go through and I say, oh, this is interesting, but I think that I will remember the presentation or the poster title in the evening, and then I don't write it down, but then I don't actually remember the title in the evening. But if I have saved or if I've just taken a picture with the QR code and opened the tab, the chances that I'll actually look at it later are much higher than if I just read the poster. So my suggestion to everyone, just do that for every kind of work that you do. Presentations, posters, source code, etc. Put it on GitHub, put it on Zenodo, create DOIs, and then put the DOIs prominently wherever you can put it. Okay? Any urgent questions? Okay, everybody's super excited about now seeing the tutorial. Again, laughing. Okay, a quick detour before I now go into PyM. EASA has developed this database infrastructure called Scenario Explorer. And it's actually, Scenario Explorer is more the tool, and we're using that for a number of different projects. For example, the IPCC 6th assessment report that came out last year used a scenario ensemble for a lot of their quantitative statements. In the IPCC report, they said, in order to meet the goals of the Paris Agreement, we have to reduce emissions by 50% until 2030. That's exactly the same sentence that I wrote 2018 in the special report of the IPCC on the 1.5 degree report. What has happened since then? Emissions have gone up, but that's a different kind of problem. We have this kind of quantitative pathways on which the IPCC analysis is done, and this is accessible via, for example, the EASA Scenario Explorer infrastructure. So if you're looking for where are the results from the ENGAGE project, data ECE EASA ACAT/engage. Where are the results from the NAVIGATE project? Data ECE EASA ACAT/navigate. Where are the results from the 6th assessment report or the scenarios that were used for the 6th assessment report? Data ECE EASA ACAT/AR6. You can go there and you can browse in an interactive way through the scenarios. You can look at how many scenarios are there, what kind of data are they reporting, like quick and intuitive playing around with the data. And maybe using that kind of data will be useful for the group work that you want to do until Friday. So maybe you say, okay, let's look at the AR6 scenario ensemble or the ENGAGE scenarios or some other, and try to derive some interesting analysis or insight that was not yet picked up in the IPCC. And the Scenario Explorer is an easy way to get into the data, but who wants to click around on a website when they can do Python programming? Yeah, I know a lot of people want to do that, but I don't. So that's why I'll talk about Python. So this is the Engage PyM tutorial GitHub repository. Just as a quick example of how a GitHub repository should look like, there is a license. Everything that Kai Eva is having a bad conscience. Yeah, everything that you do, just putting it on GitHub does not make it public. I mean, it makes it public in the sense that everybody can look at it, but it does not give people the right to actually use it. If you want people to be allowed to actually use it, you have to add a license. It doesn't hurt, it doesn't cost anything. You just on GitHub say, add a license and done. So we have a license, we have a README, where we have a couple of nice badges telling people which Python versions to use. Nico told me that yesterday he had some issues with which Python version to use. If you add one of these badges, it will make it easier for people to know which Python version can work. So very important, where is the data coming from that I'm using in this tutorial? I want to give credit to which data I have been using, and this is here very prominently in the README. And of course, most importantly, funding acknowledgement. We are all here, or at least this summer school is happening because the EU is paying us to do that. So let's say thanks to the EU or Horizon 2020 project for supporting this very important summer school. And we not just say thank you, but we can also put it as a funding acknowledgement in the README. So what is important here, there is a folder called data that has the Excel file with the data that I'm going to use and the tutorial notebook, IPython notebook. And I'll now open that and I'll run through this notebook. If you open the tutorial notebook on the GitHub repository, github.com/DanielHuppmann/engage PyM tutorial, you can follow along if you can't read it. And I'll sit down because I'll have to do some typing. Okay, so again, most important part about any good tutorial is that you carefully explain what are you doing, why are you doing it, where is the data coming from. Tutorial data source again, how you can install the Python package PyM. So you do pip install PyM -imc. I apologize, we did not realize that a package PyM already existed on PyM when we named that. And now we had to rename it on PyPy. So if you install with pip, you have to do pip install PyM -imc. I'm sorry, that was just stupid on our part, but by the time that we had published a paper with the package name, we couldn't really rename it anymore. So now all of you have to live with this inconvenience. Okay, first step, we want to import the PyM package. For those of you who've never seen Python before, I apologize. I'll just run through, and I hope that it's sufficiently logical what is happening. If you're really confused about something, then just shout. I'll assume that everybody is kind of familiar with Python terminology like import the package PyM. Okay, so we've done that, and now we do an IAM data frame. Why is it an IAM data frame? It's a data frame, as in a table with these columns, and it follows this IAMC convention: model, scenario, region, variable. That's why it's called an IAM data frame. And now we import that, and Python is telling us that it successfully imported it. And now we want to see what's in this IAM data frame. And I can just do df. So here I loaded this data frame as df. And if I just execute that cell, it will tell me, okay, it's an IAM data frame. There are two models, message and remind. There are 4 scenarios called NGFS below 2C, NGFS current policies, and then it's skipping some because it's too long to print in one line. The region is world. There are 10 variables, there are a couple of units, and a couple of years. So it's giving me an overview of which kind of data is in this data set. If I now want to see what exactly is actually happening, I'll come to that. I'll come to the meta indicators in 15 minutes. I tried to skip that, but Nico didn't let me. For pedagogical reasons, I wanted to just jump over that and then explain what it is later. But now I have to tell you specifically that I'm not going to explain it now, but later. Okay, so. Yeah. So the Excel file looks exactly like the example I've shown in the presentation. Okay, so I want to see which scenarios do I have, because here it's not showing me all the scenario names. So I do df.scenario. And I see, okay, here are the 4 scenarios that I have in this tutorial file. And then I want to see what are the variables. And there are a couple of variables that are pretty obvious, like emissions of CO2, primary energy. And then there is a horrible variable, like AR6 climate diagnostic surface temperature GSAT magic version 7.5.3 50th percentile. Like, who can work with that? Nobody. At least not if you want to do some scenario analysis. Like, if you put that in the legend of a figure, the whole legend is unreadable. So we want to look at that more carefully. And I'll define now a variable with this horrible name. Variable equals AR6, blah, blah, blah. And then I want to filter. So I want to look at what is the data associated with this variable. So I can filter by variable equals this long variable name. And it will down select my big IAM data frame to just this variable. And then I want to display it. And we are in a time series world. So I do dot time series. And now I get a table again in the IMC convention of all the variables with this horrible name, and the unit is K. I mean, yeah, sure. I mean, climate modelers, they are completely right that the SI unit for temperature is K, but come on, we want to talk to real people out in the world. So I'm going to do some renaming as a first step. So here, now I do df.rename. I want to rename the horrible name to temperature. Yep, and I have to type correctly. And I want to rename the unit from K to degrees C. And now I do the renaming and I get back a new IAM data frame that now has the variable temperature instead of this horrible AR6 blah, blah, and has the unit degree C. So just one line of code to do the renaming from the original output from the magic model into something that I can actually work with in a policy domain. And this, I think, is a very nice example for you could do this renaming yourself with 3 or 4 lines of code. There's nothing complicated about doing renaming in a large data frame. But this is much more readable than anything you could write yourself in a quick analysis script. And everybody, even people who have never seen Python before, can hopefully just read this line of code. Okay, I rename variable and unit.
When you change the unit, does it automatically change the numerical values?
Not if you rename.
Okay, so you have
But
to do that.
if you do a convert unit, which is the next example,
Okay.
3 cells down, then it will do that for you.
Is it in place or does it like?
Yes. So good question about in place. So df.rename does some renaming and gives me back a new IAM data frame. And that's why it's displayed here as it is now. But normally I want to do operations in place. Like don't want to do a copy and then a copy and then a copy and then a copy, because then I have a million copy and then my RAM runs out of memory. So what I can do, I can tell PyAM to do it in place. And then I don't get anything back because it has been changed in place. And for those people who have worked with pandas before, they will say in place, obviously. I mean, that's the pandas word for it. And if we now look at, again, do the filtering and then the time series, we get exactly the same numerical values as we get before, but now we get it with the variable temperature and the unit degree C. And of course, all of these things are super easy. My point is, it should be easy. But now it's getting a bit more fun. Okay, so now we want to do some plots. And Kai-Iva tomorrow will talk a lot more about how to do good plots. The plots that I will show you will be ugly. Managing expectations here. The aim of the PyAM package is not really to create publication-ready figures. The aim of the PyAM package is to do quickly explore something like, oh, I want to look at the temperature. I want to color it in this way. I want to slice and dice the data quickly and get something that I can look at. And then once you have the analysis, then you take Kai-Iva's course, and he will tell you how to take that into a figure that you can then put into your Nature journal submission. Okay, so if I do again just the filter variable temperature dot plot, because we obviously want to plot something, you get back something like that. Good enough. But now this kind of looks not nice. So I'll show you how you can clean that up. The first annoying thing about this figure is that you have the legend over your figure, so you don't actually see the data. So we can just do legend equals location outside right, and just looks a lot better immediately. Now, well, sorry, let me refactor it so that you can better see what I'm doing. Okay, so the first thing I did was I told it, put the legend outside. Now I say there are 2 different models and 4 different scenarios. So why not do color by scenario? So now it automatically checked which are the different scenarios, and it applies some random color to that. So all the NGFS below 2 degrees C scenarios are now in blue. And now you say, okay, actually we have 2 models, so why not do line style equals model? And now you see, okay, the remind scenarios are dashed and the message scenarios are in solid lines. And you see, well, remind is always hotter than message. So very quickly you can play around, like use line style, use coloring by some of the dimensions, and it will try to do something that is not pretty, but hopefully useful for exploring the data. So far convinced? That was the fancy part. Now we get to the very annoying part, unit conversion. You asked about that. Unit conversion is, or at least my impression, that unit conversion is where most of the errors in our community happen. Like if you go from exajoule to gigawatt hours, do you have to multiply or divide? Where do you find the number? You Google it, but it's just a mess. So PyAM is your friend. So now I again do a filter. I take only the message NGFS current policy scenario and the variable primary energy call. And you see the unit is exajoule per year. And you say, okay, I don't want exajoule per year because people in coal country, they want to talk megawatt hours. So you do exajoule per year and you do megawatt per year. And it will tell you there's a dimensionality error because it's obviously not megawatt, but megawatt hours. So not only will it get the right value for you, but it will also stop you from doing something stupid, which I think is even the most important aspect of this package. Okay, so now it's returning a new data frame, and I can look at the time series. And you see, okay, it's 4 times 10 to the power of 10, which is not very useful. So instead of megawatt hour, let's do petawatt hours. So one line of code, convert unit exajoule per year to petawatt hours per year. Done. And you don't have to worry about anything else. Yeah, we try to be as consistent here. So if you do in place, it just works. Okay, this is, I think, the most important function because it can guard all the little losing 5 minutes by having to think whether you need to multiply or divide by something. Another question where unit conversion is super important is between different greenhouse gases. We are all here to talk about climate policy. And in the tutorial data set, we have CO2 emissions, but we also have methane emission. And if you want to sum that up, well, that's a bit of a pain. Of course, Haim's got you covered. And you can do, let's do CH4. So here we have the emissions, or the methane emissions in the message model in the 4 scenarios. We can do CH4 per year, and we want to go to CO2 equivalent per year. And it works because nothing happened, because I forgot the megaton. Now it failed, as I was planning to. Okay, so we cannot convert from CH4 to CO2 equivalent because there's an undefined unit error. But if we scroll down, we have a useful error message. CO2e is not defined in the unit registry. GWP conversion with IAM data frame convert unit requires a context. So we can type context. What would be a useful context? Yes. And now which IPCC assessment report? If you talk to climate modelers, then they will be very specific that between the 5th assessment report and the 6th assessment report, the conversion factor in the GWP 100 ratio actually changed from 28.35 to 28.57 or something like these numbers. I just made this up. But okay, so if I want PyM to convert the unit with the AR6 GWP 100, then it will just do that for me. So we go from 300 megatons of CH4 to 9,000 megatons of CO2 equivalent. But in order to make Nico happy, we can also just do it with the AR5. And then you'll see it's 9,318 compared to 9,351. Or you can also say, well, what about not taking 100 years of GWP, but 20? And of course, I ran into an undefined unit error. Okay, for AR6 it works. So again, a lot of these things that we have to do and that are kind of tedious and where we often run into errors, what PyM can do for you is just make it very easy and prevent you from doing things that actually don't make sense. Sorry? Yeah, okay, okay, good point. Yes, thank you. So here the emission CH4. Yes. Okay, sorry. I did that here. So I filtered my big data set. Yeah. Waiting for the plane to pass, emitting CO2 emissions. Yeah, so up here, I down selected my large data frame to something small so that you can actually see the differences easily. And then it's I saved that at CH4DF. Okay, everybody still excited? Okay, now I'll show you one more nice example, and that's if we look at the variable list, you'll see that we have only the subcategories of primary energy. So primary energy from biomass, from coal, from gas, but not the total. And of course, again, it's a super easy computation to say, oh, just aggregate that up. And you can do that by doing df.aggregate primary energy. And you will get the data frame that now has the sum of everything that is called primary energy pipe something. So it will automatically look in your data set what kind of makes sense and use those. Sometimes that does not make sense, and then you can provide it specifically. Sometimes we have final energy by sector, but then also final energy by fuel. And if you would sum up those variables, you'd get a double counting. And there is an extended feature which allows you to not do the double counting. But for the sake of the tutorial, you just do df.aggregate primary energy, and it will do that for you. And then you can directly plot that. And then we could add all the nice bells and whistles of coloring, line styles, etc. We can look at the time series. We want to do some further analysis. But what we usually want to do is we want to add that back to our data set. So we get our model output at the most highly resolved level, like all the different fuels. And then we want to create the data set that has the entire hierarchy aggregated up. And there is a way, and it's not in place, it's called append. So if you do append equals true, nothing happens. But if you now look at the variable list, you'll see that the primary energy variable has been added. And one cool thing that a colleague at TU Berlin did as part of the Open Entrance project, it even works over multiple hierarchies. So let's say you have primary energy from gas, from fossil, like you have this very long variable list with a lot of hierarchical nestings. You just do primary energy, and it will just do it up all the way for you. So one line of code to get the entire variable hierarchy filled up.
You get double counting.
You should only use that feature if you're sure that you're not double counting. But yes, if you do double counting, if you have to do something more specific, then you have to write a few more lines, do some filtering, etc. There is also some aggregation by region, which I'm not going to show you because I'm already talking way longer than I was planning to. But just to know that what you can do over the hierarchy, you can also do over the regions. So take the 5 message regions that are the North America OECD region, add them up. Take the 5 Remind regions that are Europe, add them up to Europe. So all of these things are also there. The method is called df.aggregate_region, kind of intuitively. And there's a tutorial for it. Okay. Now, Nico desperately wanted to know about the meta indicators. So now I'll talk about the meta indicators. We usually want to categorize our scenario data. So we have, for the 6th assessment report, thousands of scenarios. And we want to somehow work with them in a way that is practical. So we do some categorization, and all these categorization indicators, etc., we push into a separate data frame that is called meta. So we have the data, which is the time series data, and we have meta indicators for categorization. And the first thing we do is we set a meta indicator called warming category, and we say all scenarios that are in my tutorial data set are above 2C. So breaching the Paris Agreement. And then I call a function called categorize, where I say actually put the warming category below 2C for all scenarios where the variable temperature does not violate an upper bound of 2 degrees. So first I put all my scenarios in one bucket, and then I have a categorization method that puts the scenarios in a different bucket. And for the actual IPCC work, you actually have 10 of these categorizations. And then you can have above 3 degrees, above 2.5, etc. But here it's like the most simple example, above 2C, below 2C. PyM will helpfully tell you how many scenarios were now categorized according to this criteria. And now I can look at the df.meta data frame. And you'll see the 8 scenarios that we have, 2 models, 4 scenarios each, the warming categories below, above, above, below 2C. So we've added these indicators. And now, the really cool thing is that we can use that now for coloring. So I look at my gas use in the scenarios. And again, I want to put the legend out because the legend is annoying. Okay, that looks nicer. And now I can just say, okay, actually, for the color, use the warming category. So it will, first I do my categorization with these meta indicators, and then I can directly use that in the plots. And now I want to say which are the Remind scenarios. So I can do line style equals model. I can do final ranges equals true. So now it will tell me for everything that has the color blue, what is the highest and the lowest value at the end. So if you have a spaghetti diagram of 1,000,000 plots, this can also be helpful that you see the final ranges. And there is a feature called fill between. So now it will fill the colors between everything that has the same color. So again, this is not for making it look pretty and putting it in a publication immediately. That's what Kai Iva's talk is for tomorrow. But this is everything. Whenever we came across something that we thought could be useful for quickly exploring the data, like, okay, let's just fill the ranges, let's look at where the scenarios end up, rather than just doing it in some hacky Jupyter notebook somewhere, we added that to the PyM plotting gallery. So that it's easy for all of you, hopefully, maybe, to save some time on the nitty-gritty technical infrastructure and actually work with the scenario data and try to tease out the interesting stories. And we have a plotting gallery, just as a brief teaser. So there are all kinds of bar charts, line charts, stacked, etc., and a Sankey diagram as well. Now, one more thing. Since nobody has run away yet, algebraic operations. So from our model, we get output, the way that our model is calibrated, but then we often want to know, well, for example, what is actually the share, or how much primary energy are we using that is not coal? And the way to do that is data frame.subtract primary energy. From primary energy, we want to subtract coal, and we name that non-coal, and we do a plot. So this is the primary energy not coal, and again, it's subtract primary energy coal. How should it be called? Plot, and you see what is happening. And again, you can apply the plotting criteria, all of these things that I've shown you before. Another thing, so this actually does not look very interesting because it all goes up. So what might be more interesting is actually the share. So we want to divide primary energy from coal by primary energy. And we name the resulting variable share. And now you actually see a much more drastic story. You see all the 2 degrees C scenarios going down very quickly. And I know that because we can use the color from the warming category. So here we see, okay, the share of coal in all Paris compatible scenarios goes down very quickly, and for the others not. One line of code, completely uninteresting result. No way you can write a paper about that, but at least you can confirm that your scenario results actually make sense by having looked at it quickly. Yes, thank you for that question. It actually says that down here. If we subtract exajoule from exajoule, the result is exajoule. So the unit on this plot is still exajoule. Here, the unit has changed to value. Yes. So if we want to divide primary energy coal by temperature, it will tell us, okay, I don't know what to do with the units. Stop.
What's wrong with that? I mean, you just have exajoule per year per Kelvin.
Okay, you can do ignore units equals true.
Who's saying what's a good unit, what's a bad unit?
Okay.
Yeah,
Yes, you're absolutely right. So what's happening is that we are not doing everything ourselves. So with the PyM package, we're trying to do those things that nobody has done before in this IAMC data format space, scenario analysis space. For dividing different units, there is a pint package in Python, which does exactly that and has all the SI units. So we just import the pint package and do some tweaks to that. So if you are wondering why does it not work, please make an issue in the Pint repository and let them fix it. And then we'll be happy to pull their change.
Sure. So I didn't know it was a Pint thing.
Yeah, but it's a good question. Like we didn't, like it would be crazy for a couple of people at IASA and Melbourne and TU Berlin to do all of that ourselves. So we are trying to pull in packages who are doing stuff better than we could wherever possible. Yeah.
Your deadline already set your unit, so it's not unlocked.
Yes. That's exactly the kind of questions that we ran into, and we said, okay, how can we do it slightly smarter? And yeah, if you do ignore units equals true, it will just put unknown. If you can also specify what makes sense. No, we don't, because that is, well, we have it within one unit. So we have in another package called IAM units. So there's the Pint package, and there's the IAM unit package, which extends the Pint package. And then we use the IAM units package here. And IAM units has deflation factors within one currency. So if you want to go from 2010 US dollars to 2020 US dollars, IAM units has you covered. But if you want to go from 2010 euros to 2020 US dollars, the question is, do you first do the conversion to the other unit and then deflate, or the other way around? And so far, nobody has been sufficiently interested in that question to write the package that this would require. Technically, it's not a lot of effort. It's more, what are the useful defaults? So how do you prevent people from doing something silly without noticing? And I think that would be a good discussion to be had by people who need currency conversion, and then either make that as an independent package, which we could use here, or implement it in the IAM units package. Yeah. Okay. Now, final 3 cells, and then I'm almost done. So we have some plotting features, like out of the box, data frame.plot, and you can set some smart coloring, etc., coloring line style arguments. But usually that's not enough. Usually you want to create complicated plots, like Kai-Iva will tell you tomorrow how to do, where you put different things together. And here we try to not reinvent the wheel, but directly build on the matplotlib package, which is the Python package for fancy visualizations other than Seaborn. Okay, Kai-Iva is shaking his head, so I guess there are others. But matplotlib, okay, yeah, okay. Matplotlib is what we use under the hood for most of our figures. And what I want to show you here as the final example is how you can relatively easily do compound figures. So first, I do a DFPE data frame. So just taking the remind scenarios and only the primary energy categories. And if I just do a simple plot, that's what it looks like. So you see primary energy total in the diff. So here I did the divide. So I divide the NGFS net zero 2050 scenario by the current policy scenario. And so if the line is below 1, that means that this energy carrier has gone down. And if it's above, it has gone up in a climate policy scenario. And purple, non-biomass renewable, is going up in a 2°C scenario, and green, coal, is going down. So one nice side illustration of that is you can also do this division across different scenarios for multiple variables at the time. But now I want to look at multiple different scenarios. I want to see how do they compare. And I want to put these scenarios, these plots directly side by side. And for that, I want to use the matplotlib package directly. I have a baseline scenario, which is current policies. And then this line here, let me pull that out first, tells me what are the scenarios that are not the baseline scenarios. So this is basically from the set of all scenarios, remove the baseline scenario, and then what is left are the 3 scenarios that are not the baseline scenarios. Now, this is some matplotlib functionality. I create a space, like a large figure that has multiple figures embedded. And it has 1 row and length of the scenario, so 3 figures side by side. And the fixed size I can specify. So now I have 3 empty plots side by side. Now I iterate over the scenarios. So here I enumerate the scenarios. And now I want to create, or I want to put this plot here, but not for 1 scenario, but all 3 scenarios simultaneously into these 3 boxes that I have created. So I put that here. And I don't take always the net zero 2050 scenario, but I take the scenario over which I iterate. So I say first scenario as second scenario, and now draw the 3 plots in the 3 boxes. And now it's not working as I expected. On purpose, obviously, because I did not tell matplotlib that it should put the figures into these boxes. And for that, I need to tell it which axis I'm using. So now it's putting the first scenario here, the second here, the third here. But that looks bad. I mean, you don't actually see what's happening. So I can play around with the legend, and I can just say, get rid of the legend. So now at least I see the lines, but I don't have the legend. So that's also kind of bad. So what I can do is I again use my the location thing that I did earlier. Sorry. So earlier I used this dictionary location outside right to put the legend outside of my figure so that it doesn't mess up the entire thing. And what I want to do now is, if I'm actually in the third figure, then show the legend outside right and otherwise don't. And I can do that in a very Pythonic, elegant way, saying, put the legend outside right if I equals len of scenario +1, else false. I hope this works. Yes. Okay, no, it did not work. But it's not showing it. -1, yes. Okay. So now I've iterated over the 3 scenarios that are not my baseline. I have for each scenario computed the share relative to my baseline. I've put them in 3 boxes side by side. I have only 1 legend, which is outside, so it's actually readable. There's one thing that is still ugly here, and that is the title. And I can also directly access the axis object, and I can set the title. And set title, I want to use the scenario name for the title. So here I basically is x1 says, or x of I says, take the box which you're currently operating on, and set a title. And as title, set S, which is a scenario name. So now I know the first one is the nationally determined contributions. The second is the net zero 2050, and the third one is the below 2C. It's still not publication ready, but with a couple of lines and a little bit of practice and a good tutorial and documentation, it's relatively easy to put together these figures to try to tease out the actual story from your scenario results. Because now that I've talked for this whole thing for 1.5 hours, that's not why we're here. We're here to do cool models and interesting scenarios, and then do relevant scenario results and policy insights and recommendations, etc. And the whole point of the last 1.5 hours was that you can spend less time on the thing in between if you use a well-developed package like PyM, if you're in the Python world, or for R, there are people at PIC who are developing something similar. So the main takeaway is don't reinvent the wheel, use tools that already exist. Final pieces of information here is that here I've included the Excel file with the data in this tutorial repository, just because that's the easiest way to work. But I've briefly shown you this IASA Scenario Explorer front ends where you can go and explore the data. You can also query the data directly from PyM, from the scenario database infrastructure. So there's a tutorial for that. Here's a list of all the public scenario explorers that we're currently hosting. So for example, the Engage one from the Engage project, AR6 public for the IPCC scenarios that were used for the 6th assessment report, etc. And then you can simply do, a connection to the IASA database. So PyM IASA connection, connect to IMC15, which is the scenario database related to the IPCC special report on 1.5 degrees C. And you can directly do pym.read IASA, get the data from there. Rather than having to go to the Scenario Explorer, download it as an Excel file, save it on your desktop. Then you go home, want to continue your work, but actually the file that you downloaded is on your desktop and you don't have access to it. So there are a couple of these simplifications built in that allow you to easily work with scenario data in this larger IMC ecosystem.
Like conversations that are done within like there's somewhere you can already take a subset of scenarios, for example, like say another one's in chapter 3 or in C7 or something like that.
Yeah, so the question was about whether the meta indicators are there. Yes, the meta indicators are included in the public scenario explorers, and you can download them also with this API. There's a bug, and you currently cannot actually filter them. So you'll always get everything, and we're working on fixing that. But ideally, the intended use case is that you can say, give me all the scenarios that are in the category below 1.5 degrees C in a filtering language like we're using in the PyM package. But there's a bug currently, and the filter is lost on the way, and we'll fix it.
From what I understood, this package needs that the data to be provided in the IMC format, and there's no direct way to have it, or it is.
What do you mean direct?
So the models don't output the data in the IMC format.
Yeah.
So the modelers need to provide, like, to transform it before running this package.
Yes, exactly. So the one step that you have to do is to get from your model output or modeling framework output into the IMC format.
Mm-hmm.
There are a couple of tutorials for how you can do that. But there's a tutorial called importing various data table formats. So this could be helpful for you to write a script that takes your model output and puts it into the PyM format, and PyM format equals IMC format. The osmosis team is currently working on a osmosis module that does that for you, so that hopefully in a couple of weeks, any osmosis model will be automatically exportable to IMC format. There are some people in the Times community who are thinking about that. So again, ideally, if every modeling frameworks, or if 1 or 2 people for every modeling framework make this extra effort and do that as part of the modeling framework, then it will be a big time saving for everybody using these modeling frameworks.
Okay,
What is required is this coordination effort to actually implement it. But there are a couple of initiatives and we have some tutorials, and I'm also happy to help if somebody wants to get started here.
I think every model that has ever submitted anything to database should have.
But maybe that was everything in a package or something. Like that.
I mean, maybe I don't know if you can add something about like if there is some official variable definition and region definition that can be used for this purpose, or some efforts to.
Yeah. Okay. I think yeah, these are the things that I thought are most useful. I can go on and talk about where we host variable definitions. If somebody wants to run away now, I'm not offended. But I can talk a bit more about how we do this variable list. So what for primary energy / biomass, that's obvious. But then the further out we go into projects, the more specific different projects becomes, the more of a headache it actually becomes to manage these code lists. And then the Navigate project introduced a different way of specifying CCS versus CCU compared to the Engage project. And then when we want to bring together the Engage and Navigate scenarios into the EU Climate Advisory Board scenario ensemble, it's basically a month of my time to try to clean that up again. What we are moving towards is a harmonized structure for that. And I can show you one example from the Open Entrance project. So Open Entrance is a Horizon 2020 project that ended last Friday. And here we use that as a prototype for developing a more standardized approach for managing these code lists. Code lists being list of variables and the units, list of regions, list of sub-annual time resolution. So do you call it January, J capitalized or not capitalized? So you have to specify that. And if everybody does something different, then it's a mess. What we've done here in the Open Entrance project is, so that's a GitHub repository where we manage all of that. There's a folder called definitions. There is a folder called variable. And let's start with energy. So energy final. So this is a YAML text file. YAML stands for yet another markup language because it is yet another markup language. But it is quite easy to read, but can also be processed in an automated Python or R workflow. So it can be read by computers quite easily. And here basically you see, okay, this is the variable final energy. There is a description. There are some additional attributes, and it can be provided in exajoule per year or gigawatt hours. And then if you go down, okay, there's a variable called final energy for non-energy use from a list of industry sectors from a number of final energy carriers. And then there are other YAML files where we have the specific list of what are the industry sectors and what are the energy carriers that can be used. And what happens if a modeling team in the Open Entrance project uploads their scenario results to the IASA Scenario Explorer for the Open Entrance project. Their data is validated against these lists. So if they are having a typo in some of their data processing, and it's not called final energy, but final energy, with the Y missing, all these things happen all the time, unfortunately, then our infrastructure will raise an error and will say, sorry, the variable final energy is not defined. This upload is rejected. So we are moving into a direction of having these YAML file for hosting the code lists. We have a open source Python package, obviously, called nomenclature, which does all the validation and the machinery behind. Also for region processing. So if you want to go from your native model regions to the R5, R9, R10 regions commonly used for comparison, the nomenclature package together with some YAML files can do that for you. And now in the Prisma project, that will basically be my summer project, is to look at all the different variable definitions that have come up in Open Entrance, Engage, Navigate, ECEMF, I don't know how many other projects, and try to bring them together to a new master variable list that can then be used for the next projects. To avoid this headache that in Navigate is called CCS underscore something, and in Engage it's called carbon sequestration pipe CCS something.
There's also somewhere a feature that there's anywhere a feature that when you provide scenarios from different research groups or different models, it compares which variables are reported by which model or not.
No, we don't have that yet. What I can say is that PyM and nomenclature would give you all the tools to do this in a relatively efficient way. I've done that for the IPCC SR15. Yeah, writing these scripts is relatively easy after you've validated that they all have the same format and they don't have any typos in the variable names or are all using the correct units, which is what the nomenclature and these YAML definitions are doing. Yeah, one thing that I've done for the ECMF project was actually write a script that adds a meta indicator to every scenario, whether the model has country level resolution, R5, R9, or R10 regional resolution. So different regional representations of the world, because where we lose a lot of time is figuring out, can I even compare the image model with the pipestar model? And or which regional resolution would make sense? And here there are some scripts usually developed as some prototype in some project. And then if we find that they are useful, they are being added to the as a standard feature either to PyM or nomenclature.
Did I see correct? There was a feature of downscaling also in the model?
Yes,
there a bit what that is.
We have a very simple downscaling feature. Downscaling here, you have to give it the weighting factors. So if you say these are the values, or let's say you have Europe with or EU 27 with 27 countries. If you give it a matrix where you say 10% should go to Germany, 5% to Italy, 3% to France, apply that to the final energy consumption, then PyM can do that for you. What we want to do as a next step is actually computing these weighting matrices from some other information. So we have only the latest step of the downscaling workflow that's implemented efficiently in PyM. The steps to get to this weighting matrix is something where Fabio is working on at IASA, Matt is working a bit on, but it's all not yet at a level that it can be part of the main package.
Yeah, I mean, can I have two questions? Yeah, thanks, first of all. Now there's time for more questions. I don't know exactly.
I don't know how we still have 20 minutes till the coffee break.
Yes, yes.
So if
for-
people want to now, like if everybody's super eager and wants to install PyAM right away and start working with it, I'm happy to sit down with anyone and answer more questions
Okay.
bilaterally.
So maybe then just 2 or 3 comments and questions. So one on, so I mean the AR6 database. I think you used the EU advisory board, but I think AR6 really can be used. I mean for many applications, and I think a lot of papers are written on using it for any kind of post-processing, computing all kinds of indicators. So I think that may be the easiest use case, including for your group projects, if you wish. Yeah, if you have questions, feel free to ask him. Secondly, on the question of how to generate the YAML format from a model, I think that's really an important point. And of course, I mean, it depends on the model, right? We did it for our models, but your model, every model has different variable names, region names. So in the end, that no one can provide it for you. But I think that's really also, yeah, it would be nice to have in some projects, we had some group activities of how to share that, because like in the figure that Roberto actually showed yesterday, we saw that basically, and actually that's one criticism of the IPCC, right? That like, I don't know how many, but like 15 IEMs or so generated like 95% of the scenarios. One reason being that it's a lot of work for to generate this data, many variables, final energy price. You saw all. I mean, these were just a few, but there are like hundreds of variables, and then also being correct, vetted, the right units, etc. So I think it's really, yeah, especially for national modeling teams. Really, I think for the next IPCC report, there will be a great call for people to get their models, produce this data, be able to upload it. So I think that's a big community effort. A lot of scientists and modelers in a lot of countries will be working on. So really important work here. And a question to you maybe is, so you mentioned the validate function, but I think you didn't get into it. And can you do like add some historical statistics, maybe to some plots, or at least check that the range is reasonable for some values?
Yeah, so I would do that. First, you need to get the historical data into the IMC file.
Okay, so it's not there. There's no data in the package itself, like historical data.
No.
There will be.
Yeah. Okay. So, right. If somebody feels interested to take, for example, the IE8 data and put that into a format that can be easily used with the IMC format, that would be super useful. And then you could do something like pull message and remind scenarios from AR6, pull IE8 data from this other package, put it together in a plot. Super easy. And then you can do something like validate primary energy in the year 2020 has to be within the range of the historical value plus minus 5%. So all the functionality is there. It's just that nobody on our end had the time yet to prepare the data in a way that it can easily be reused outside of, well, that it can be used out of the box.
Yeah. Okay, any other questions? Anyone managed to run the Jupyter notebook, him or herself? I see several opened it and ran it.
Yeah, I'll be around this afternoon if you have any questions or want to volunteer for doing this NetCDF integration.
We're at 20 minutes now, I think. Yeah, it's not very important to be recorded, but I think we have 20 minutes, and maybe it's a good idea to try to install it already. That you make sure that it works, that the first thing at least works, because it can be very useful for your group work, and if not for the group work, for your normal work. So yeah, I can also have a break, of course, but
and also a good starting point for the session tomorrow by Kai Ivar on how to do actually nice figures.
Exactly. So Yeah, I'll have something to say about it later about what you can install and download stuff in advance, but that's for later. But for now, I think it could be useful to already try to have something running that you can work with. Just
yeah. So yeah, I mean, maybe a question of curiosity. So as you were asking at Python, because there is also the version to use it through Articulate in R. It's also in read my docs page, which is personally what I'm using because I'm really not a Python person. It works quite well, but if someone has questions, I think, I don't know if you, but I mean, yeah, people can also answer it if you want to run it in R. I mean, out of curiosity, I mean, who is using Python as his or her main data analysis language? We can have a small sample survey. It's not so many. Who is using R as most? It's a bit bigger. I think it's like 2 to 1 almost. Yeah. Okay. Any other language? Julia. Yes, makes sense. So there seems to be, yes. Maybe that the R version might be interesting. Maybe there should be also an R package one day that kind of. Yeah, I mean, it works quite well. Yeah. So if you want to try it out or if you have questions, I think, I don't know if you use it or you debug it, or you support it.
No. Yeah, but okay. So there is an R package called Reticulate, which allows you to use Python packages directly. And there is a tutorial for this. So you do pym import pym, and then you can do something very similar to what I've shown in the tutorial, but translated to this typical R notation. And for plotting, I don't think it makes much sense. Yeah, because plotting in R is generally nicer than plotting in Python. But where it is useful,
Kai might not disagree. I don't know.
Okay, Kai disagrees, but what a lot of my colleagues actually use it for is to use pym to query data from the IASA database, download this in Excel, and then continue working in R. Of course, if somebody would be interested in doing an R shim around pym, yeah, I'd be happy to assist.
We should create that.
There have been several initiatives. There are a couple of people at PIC who would be interested. There are a couple of people at the US EPA who would be interested in that.
No, we have one, but we could share it actually. We can have to. We should extend it. Or someone else here, yeah. I think there's. I mean, this is a lot of open source and free contribution to the community, which is helpful. Of course, it's not exactly what gets you published immediately, but it can in the long run, and it's definitely useful. No, but there was a paper on the package, so yeah, it's possible. On the publication, a curiosity question. I mean, but so you say the figures are not so nice. I mean, I think they're still pretty decent. And I wonder if there's any papers using the pym as it is to produce publishable figures. I mean, you see much worse figures in publications actually. So I think it's possible, right?
So all the figures in the IPCC special report on 1.5 degrees C in chapter 2, where I was the chapter scientist, were created directly with pym.
That's pretty publishable, I would say, IPCC right now. Great, yeah. So I think it's possible also with that directly, and yeah. But then you can also do everything else on top of it. Yeah. Yeah. So I don't know. We can do. I mean, you can continue trying it out. And what time is it? I think we have plenty of time, which is great. Which leaves more room to the group work actually, which I'm sure. Yeah.
To say thank you.
I just want to take a second to say thank you to you guys who are developing this for the community. It's extremely useful, and it has made the work for IPCC report a little less complicated. So yeah, and it's also an encouragement to everyone in the room to use it and contribute to it, because it makes things a lot more easy, transparent, reproducible, and it's very valuable, I think, for research. So yeah.
Thank you.
Makes life a lot easier. Recommend, yeah, I mean, do that too much. Get information now.